When working in Fusion 360, we usually start with making a sketch. And when we're sketching, we can use lots of different constraints to have Fusion 360 control the different sketch objects. Of course, we can give each of our sketch objects dimensions, but sometimes we want to give them constraints in addition to specific dimensions, so we can model parametrically in Fusion. I'm going to create a sketch on the ground plane. I'm going to select L on my keyboard, click, press Escape, select L, draw, click, press Escape. Now I have two lines. I can move these lines around, and I can move the points around. Up at the top of the sketch menu, you can see that there are constraints. We have many different types of constraints. I'm going to start over on the left with the horizontal vertical constraint. If I select this, then click one of the lines, Fusion tries to think, is this a horizontal or vertical line? And then it makes it horizontal or vertical. This one is closer to vertical, so if I click it, it becomes vertical. This also works with objects. For example, let me draw some circles. Here I have two circles. I'm going to click the horizontal vertical constraint. I'll click in the center point of the circle. And now these circles are horizontal and vertical. If I move one circle, the other circle comes with it. They will always be in a horizontal vertical orientation. So this is very convenient. I will delete these objects. Let's talk about the next constraint. We have coincident. So this means two things at the same spot. So I'll draw a line, press Escape, draw another line, press Escape. And if I click the coincident constraint, and I click this point and this line, now this point is always coincident on this line. So now if I move this line, it always is on that line, even if that line extends in imaginary space. So you can see how it's like a laser beam on this line, but if I move it up, that line changes along with it. This is a very powerful constraint. The next constraint we have is the tangent constraint. So if I have a circle, I have a line, and I click the tangent constraint, I can click this circle and this line. And now this line will always be tangent. I can then move the circle, and you can see that this line is tangent to that point on the circle. Now, if I want this line to be longer, I can extend it. You can see it will be tangent on that line. If I rotate this line, you can see it rotates around the circle. Tangent can also work with a rectangle and a circle. So if I have this rectangle and then I create a circle, then I can make this edge tangent to this edge and this edge tangent to this edge. Now, if I change the size of the circle, the box changes with it. I can move the circle down by moving the point, and it will always be tangent with the box. So tangent is also a very powerful constraint. The next constraint is the equal constraint. For example, if I draw a circle of this size, and I draw a circle of this size, and then I select the equal constraint, and I select this circle and this circle, they're both the same size, and they'll stay the same size. So now if I change this circle, and I make it smaller, they will become equal. And we can combine constraints. So if I want to have the horizontal constraint, I can click this circle, and now they're horizontal, and they're still equal. So if I move them, they will stay equal to one another. This also works for lines. So if I have two lines, I select the equal constraint. Now both these lines will always stay the same length. No matter what I do, they'll become the same length. Now let's talk about the parallel constraint. This one is pretty straightforward. I could draw a box. I could draw a line. And if I click the parallel constraint, I can make these two lines parallel. So it doesn't matter if I even have a rotated box, I can select this line and select the parallel constraint. And now these are locked to parallel. Similarly, if I draw another line, press L and draw a line, I can click the perpendicular constraint. So I can click this line, and they'll be perpendicular. Notice that the line isn't even touching. I can combine the coincident constraint, click this point and here. And now it will be perpendicular and coincident. So that will always happen, but it can still move around. Notice I can move this line up and down, and it's coincident on this imaginary line, But the rectangle becomes longer because it has to stay touching. And it's always going to be perpendicular no matter where it goes. The next constraint is the fix-unfix constraint. This keeps something locked in size and location, but we don't want to use it. We actually want to fully define our sketches, and I'll talk about that in a future video. The next constraint we have is the midpoint constraint. So if I have a rectangle, and then I have a line, I can click on the midpoint constraint, and I can click on this point, and now that will be always in the middle of that rectangle. Even if I make the rectangle bigger, that will always stay in that midpoint. So that's very convenient. You can do this for many different things. You can use it on two lines. So if I have a line and I click on midpoint, I can click on this line, and they will both be in the midpoints. Even though I can rotate the lines around, they're always going to stay in the midpoint. The next constraint is concentric. So we can have a circle, and I can have another circle, or I could have an arc, and I can make these concentric, meaning their centers will stay the same. So I click the concentric constraint, I can click this circle, and now they are in the middle of each other because they're concentric. And if I change the size of this circle, it stays, but I can't move it. So if I move one, they both move. And I can also do this with arcs. So if I click the concentric constraint and I click this arc and this circle, now all of them are concentric. I can still move the scale of these, so I can make this arc bigger, but it'll always be concentric with those other pieces. That brings us to the collinear constraint. For example, let's say I have a rectangle, and then I have a line. If I select collinear, I can select this line and this rectangle, and now they are collinear. So if I'm moving the line around, it stays collinear, and the rectangle grows with it. The next is we have symmetry. So this is collinear with this. What if I have two circles? So I have a circle here, and I have a circle here, and then I want to have symmetry. So if I click this circle, then I click the next circle, and then where do I want them to be symmetry? I'll select this line. So now if I move this line, the circles stay perfectly symmetrical on this line. So that's very helpful. And then the last sketch constraint that we have is the smooth constraint. So for example, if I grab a spline, I go from this point to this point, it looks like a straight line, but we can move these handles. If I click the smooth constraint, I can click here, and now I have perfect smoothness. It doesn't look like much there. If I click here and here, I also now have perfect smoothness, and I'll delete the collinear constraint. So you can delete constraints by clicking on them. And now I will move this line, and as you can see, I'm getting this perfect curve between them. So it will always make this perfect G2 level curve. So that's a nice constraint as well. So sketch constraints are very important, and I'll show you how to fully constrain a sketch with dimensions in the next video.